Good afternoon, everyone. Apologies for the delay. Without further ado, let's start with our next presentation by Moses Schwartz on Security Automation Simplified. Welcome.
Thanks. Hi, everyone. Thank you for coming. Is audio good, everything? Okay, sorry about the delayed start. Computers are hard. I think most of you know that. So I'm Moses. I work at Box as a security automation engineer. My whole job is building automations that make our cert run more efficiently. And we're running our whole big DIY Python stack that we built over the years. There are a lot of vendors out in the space, a lot of them charging a lot of money, one of them getting bought for $500 million. But you don't actually need to buy a big platform to get started in automation. And I'm hoping to kind of give an overview of how you can start doing this stuff in Python pretty quickly. So this is a really generic, high-level overview of the infrastructure that you usually see at a cert or SOC, any kind of security monitoring setup. You have a whole bunch of logs that feed into a SIM, which in my mind is basically equivalent to a database that can also send alerts somewhere. Those alerts usually end up in a ticketing system, and then Freddie Mercury there goes and looks at that alert, looks up the username in Active Directory, looks up hashes in VirusTotal, looks up their playbook documentation, maybe it's in Confluence or something, and really just does all these manual steps that could be automated. So if we actually want to go and start automating this, there are a couple ways we can go. You can look at one of these centralized solutions. You can go buy a big platform or to start building something giant that takes care of everything. Or you could start building out just little pieces of automation. I call this distributed, just a couple tools that work together where you can point a webhook at the other and get one little task automated. That's a fine place to start. It doesn't really scale up to build more advanced workflows, but there's nothing wrong with starting small. Now, building an automation orchestration platform that works for everyone and every use case is really hard, which, like I said, is why there are these big vendors that are getting acquired. But building one for your own environment is a much more tractable problem. You only have a few tools that you need to tie together. You only have a few use cases, and you already know your exact workflow. So you don't need to build a generic workflow engine. You just need to implement that one workflow. So I'm going to walk through an example, kind of end-to-end, using the tools that I'm most familiar with. It's going to be Splunk, JIRA, and Python, to build a basic security automation system. So we're going to start by just going into Splunk and developing an alert. You do that just by going and searching, developing a query to find the logs that you want to alert on. This is the first step. This query found some faked up data that I dropped in there. We've got a host name, MD5, username, things that we're going to want later on. Then we're going to go into the create alert page, and we're just going to take that same query, drop that in there, put it into its own app. That's a Splunk best practice, and it makes a lot of things a lot easier. And then we're going to set it to run on a scheduled basis. I like to specify this in the cron syntax, but they have little drop downs to help you choose and specify a time range. This is how long back your query is going to look. It wouldn't make any sense to have something that runs every 10 minutes and looks at a 10-minute time range, because then you'd have gaps, and you don't want to double alert either. And we're going to scroll down, and we're going to say when to trigger. We're going to say to trigger for each result, because Splunk only puts the result from the first entry in the actual webhook payload. And then we're going to specify a webhook trigger action. And we're going to put in here an IP address and this /Splunk _ webhook, which is a server that we're going to go and write on the next slide. So here's version 0.1 of automationserver.py. We're going to use Flask, which I really like. It's a really lightweight Python micro framework and it's commonly used for developing APIs. There are also a lot of projects that make it easier to build APIs on top of Flask. I might go more in depth on those in a later presentation. So we're going to start by writing basically our hello world endpoint or a status endpoint. These are super useful because you can check to make sure your app is actually up after pushing an update. Makes it easy to integrate into a status monitoring system. And then we're going to write our Splunk webhook function. So this @app.route syntax is one of the weird things about Flask, but it's just the way you do it. We're telling it /Splunk webhook. It's going to go and listen at that URL basically, and when it gets called, it's going to go call our function, and it's going to provide this request object. So this is really just going to be a few lines. We're going to go grab that request object, pull the JSON out of it, and then it's kind of an insight into my development process, not what we're going to get at as the end result. We're going to dump that into a file just so that we can open it up, we can read it in a Python interactive terminal, we can figure out what data we need to get out of there, and then we can write it in our next step. So we're going to go into our automation server here, and I literally just spun up a droplet in DigitalOcean and SSH'd in. It doesn't necessarily have to be a lot of setup. And I run Python automationserver.py, and that'll start up the built-in Flask development server. You don't want to run that in production, and you definitely want to have the debugging features turned off because they are awesome, but they allow remote code execution by design. So this server is now just going to sit there waiting until we call it. We could go curl that status endpoint for starters to make sure it's up, but then we're just going to wait until Splunk fires that webhook. It'll print out the log showing that we received that, and then I'm just going to Control-C out of it and print out the first few lines of that JSON file, and that is what the JSON coming out of Splunk in that webhook looks like. So that's pretty cool. We got the first step working. I'm going to briefly kind of pivot into secret management. This is a problem that balloons to be unbelievably complex. But for the simple example, what we're going to do is just keep a separate Python file, calling it settings.py, and we're going to put our usernames and passwords in there. You can actually use this approach in production and just push this file to your server manually or with configuration management. Bonus points if your configuration management has built-in secret management, then it all just works out kind of perfectly. So in the code examples later on, there are going to be references to settings.username, things like that. I'm not going to come back here, but that's where it's getting those values from. So we're going to go back to this automationserver.py. And now that we've got that webhook and we know how to parse it, let's just go and create a ticket in JIRA. So to do this, I'm going to write a new function, create JIRA issue. And it's really just 2 lines, just broken up because they'd be really long lines, to use the Atlassian JIRA SDK that they provide for Python. We connect, we give it our username and password, and then we just say create issue, and we provide the data. We're going to drop the full alert body into the description field, and we're going to name the Splunk alert : name of the alert. Now, right here, we could go and start setting fields or assign this ticket or things like that. So it's kind of already a step ahead of just having them send an email and create a ticket or using their provided add-on. But we're not going to add a whole lot to this function. We're going to instead do that in a couple steps with JIRA webhooks. So this is what we get the next time that Splunk save search runs. It will hit our web server will reach out to JIRA, and bam, we have an issue created. The first time you see this is always kind of magic to me. Like I wrote something and it actually worked. So it's pretty cool. Look, there's JSON in that description. It's not super useful, but we can do something about that. So we're going to go into the JIRA webhook settings and create a webhook. We're going to give it a URL that's pointing back at our server, and I just made up a name, JIRA mockscan created webhook. And you can give it a filter to say only fire on these tickets. And if you scroll down further, you can trigger these webhooks on all kinds of ticket events, like transitions, closed, opened, assigned. But for now, we're just going to only look at tickets being created, just because that makes the problem easier. So we're going to go back to that automationserver.py. I forgot to mention, if anyone can't read this, The slides are uploaded to Sked, so you can pull that up and follow along if you need to. So this is kind of the biggest chunk of new code that we're adding. We've got a JIRA comment function, which is really similar to that create issue one. It's just going to connect, pull that issue out of JIRA, and then add our comment. Then we've got another one, which is going to receive that webhook from JIRA. This one has a bit of ugly JSON. Probably could have cleaned that up, but honestly, like, ugly JSON parsing is half of my job doing security automation engineering. So we're going to pull that description out of the JSON, and then we're going to actually load the JSON that was in the description, which was the original Splunk alert. And then we're going to pull out a username, an MD5, and just post those to the ticket. So now suddenly we have a couple fields being extracted and posted to our ticket. We already had those in the ticket, so this isn't super useful. But we can go and make it a little bit cooler. So this is adlookup.py. It's just a little bit of code to do an Active Directory lookup. I won't go into details in the code here, except to say that LDAP 3 is so much better than Python LDAP if you ever want to talk to LDAP or Active Directory. So basically, we're just going to connect to our AD server, send it that username, and it returns a JSON object like we see on the left. We're going to go back to our automation server code and just add a function that's going to call that module we just wrote. That module was not tied in any way to Flask or to the rest of the application. We could pull that into other modules. But in this case, we're just going to do a lookup, and then we're going to do a little bit of string formatting to build what we want this comment to look like. And then up in our mock-scan created function, we're just going to add a call to that function, the new one. And now right away in our JIRA ticket, we have Active Directory details for the user in the alert posted to the ticket. Then we also had an MD5. And when I see a file hash, my first thought is to go look it up in VirusTotal. So we're going to write another script, VirusTotal.py. Again, no dependencies on Flask, no overhead really. We can just develop this like we're writing a little Python script. And this is pretty much copied and pasted from the VirusTotal public API documentation. And if we give it that hash, it's going to send us back a JSON object like that. So I'm going to go in, pull out a few pieces that I think are most interesting. Probably the positives, the total number of scans, and a link to the full results. And then we're just going to add it the exact same way as we did the Active Directory lookup. So this is where it actually starts to get pretty cool. Now we have tickets being created, and then automatically those first two lookups that our analyst would be doing are already in the ticket when they get to it. So this is kind of what our infrastructure looks like now, right? We have, to recap, because the flow is a little bit complicated, we have those alerts reaching out to our automation server, which reaches out to JIRA and creates a ticket. And then that create ticket part is done. You could also receive a ticket via email, and it could work the same way. After that, we rely on the JIRA webhooks to let us know when a ticket was created or changed, to reach back to our automation server, and then we run whatever functions we have to find for that webhook endpoint and post details back to the ticket. Now, the nice thing about this approach is that we can literally automate anything that we can write a script to do. So just the really low-hanging fruit, we can go and populate ticket fields, search for previous tickets, that kind of thing. I know that a lot of the time when an analyst pulls up a ticket, that's the first thing you do. You've got to classify it as type of threat, check a few boxes. We could run a Splunk search and post the results to it. We can look up DNS and whois records. I don't want to read everything here, but you can definitely upload files to Box. You can connect to a smart device. You can set up a light to flash if you have a critical alert. I mean, really anything that can be put into a script, we could automate here. There are some considerations about how we're going to run it, though. So in that example, we had a single function that did an Active Directory lookup and a VirusTotal lookup. And the one problem there is if that Active Directory lookup fails, say just a network hiccup or they're rebooting the server, then the whole thing is going to error out, and we're never going to do that VirusTotal lookup. So if you're actually going to go to deploy this, you definitely want to think about ways to make it asynchronous, by which I mean separating the jobs so that one failing doesn't kill all of them. There are a few ways you could do that. One kind of intuitive way would just be to set up a JIRA webhook for each ticket enrichment that you want to run. Then you have to go and manage a whole bunch of JIRA webhooks, but we can specify with that filter that we want all of our carbon black alerts to do an Active Directory lookup, and we want all of our OS query alerts to do some other lookup. And you can add as many as you need. I'm not sure if they actually have a limit on how many webhooks you can use. I haven't tested that. Or you can build out your code to actually do this asynchronous stuff itself. We could use Celery and RabbitMQ or something, or we could use async.io, which I'm going to learn about any day now. Or we could go and use a DevOps platform like Jenkins. I've seen really complicated stuff built on top of Jenkins. Basically, it's a service that just runs things when you tell it to. That's exactly what we're doing here. So there are a lot of opportunities to use tools that are not actually marketed at security, but could still fit in this use case. If you're a cloud native, we could also do this all in AWS Lambda jobs. It's actually a really good fit. This entire thing could be Lambda jobs, and then you don't have to worry about your infrastructure for the most part. Going to follow on to this, if one fails, they all fail problem. Everything is going to fail at some point or another, even if you think it shouldn't. Logging in and exception handling is vital. The biggest thing is knowing when something breaks, even if you don't actually fix it right away. Just having that visibility into your infrastructure of when things run, when things break, it's really critical when you actually get this running in production. So once you do have it running in production, the next step is that you've really got to do some metrics. You've got to start trying to integrate automation into your process. So I think that security operations is kind of converging on a model similar to the DevOps mindset, where part of your time always has to be spent automating, and you've got to quantify the impact, quantify the time spent on tasks. This little graphic in the corner is similar to something that my team actually sends out in our weekly status updates. We go through the logs and say, every time we ran this lookup, that saved about 2 minutes of analyst time, and we got our cert to say, yeah, that's about right. And then we just add it all up and end up with something like 81 hours saved in a week. That is really compelling to management, and it really justifies the time spent on this automation. So, takeaways, the stuff I hope you guys got from this kind of basic intro talk is that security automation isn't magic. You can actually start building these things out pretty easily with a little bit of Python. Like, for real, there are a lot of analysts who could set this up and start using it in their environment. And I hope I can kind of encourage that, even if you can't go and buy a super expensive automation platform. You can use Jenkins if you've got Jenkins. If you're standing up something new, you could use a tool like StackStorm, which I've used before, and I thought was pretty cool. But there's just lots of options, and there's so much low-hanging fruit, right? So many opportunities in a lot of certs and SOCs and even other IT operations areas where just doing some of these lookups directly into the ticket before an analyst ever gets to it can save hours and hours of copy and pasting between browser tabs. And then finally, I just want to say, I think this is like the coolest job in the world. I spend my time trying to make the rest of my team more efficient. When people say they have a problem, I can go and fix it. And I can ask them the next day if that fixed it. And we can collaborate. It's a really neat place to be. It's different from normal software development. It's different from normal incident response or security analyst roles. But it's pretty awesome, and it's a great way to get into security for developers and a great way to get into development for security folks. And like everyone else here, we're hiring. So, any interest, let me know. With that, I think we've got about 5 minutes left, and if you guys have questions, I'd love to answer them. We have this Slido thing, and if we don't have questions there, raise your hand.
I agree that security automation is amazing, and it's one of the best jobs, at least in my opinion.
Awesome.
Do your metrics include the time that goes into building, maintaining, and troubleshooting?
So not quite as much as that hours saved metric, but our actual status report shows that these are how many bug tickets we worked and how many new development stories, and we have some graphs around that to kind of show the effort that's going into this, as well as new lines of code added or removed from our repos.
Can I ask? Well, I'm going to ask a follow-up question. So then, how do you convince leadership or management to devote some man hours to automate?
Well, so at Box, I'll say I am unbelievably lucky. We really built this out from the start, believing automation was important, and we now have a 4-person full-time automation team. I know that's not the norm across the industry, but in another place I worked, I actually just kind of started automating. And when everyone loved it, I was able to show the value, and it pretty much became my full-time job. So I don't know if that answers your question.
There's time for one more question.
In your slide, you mentioned that logging exception, even the code is perfect, is not good. Is it in dev environment or production? Because basically we all logging all the exceptions.
I'm sorry, could you say that again louder? Or
in one of your slides, you mentioned that logging handling exceptions is not a good idea, and even your code is perfect. Do you mean that we don't have to log any exception?
Oh, so exception handling and logging is critical, but what I was trying to say is actually fixing that exception doesn't have to be automated. You can go and fix it up later as long as you know that it happened.
Okay, on behalf of BSides, we thank you for your presentation, Moses.